Jai Hind everyone. So today we are going to start about the next topic, that is relation in discrete mathematics. So in the previous video we have discussed about the set theory, which is unit 1. So this is the second part of unit 1, which is called relation. Now what do you mean by relation? Relation is just indicate the relationship between the element of a set which are represented using the structure called a relation. Means we can represent the element of a set and one element is relatable to the other element of a set is called a relation, which create some ordered pairs. Relationship between a program and its variables, or we can say that it may create a ordered pair. Means one set, the element of a one set is relatable to the elements of another set. Now, relation is just a pair of cities linked by airline flights in a network. Means any set where the properties of any set is relatable to the properties of another set. In the most direct way to express a relationship between elements of a two set is used to ordered pair. As I have said earlier, we have conduct ordered pair in a relation. Means we analyze some ordered pair and create a relation. And relation is totally depend upon the Cartesian products. So further we will discuss about what do you mean by the Cartesian product. First we have analyzed if any ordered pair in a consist in a set, it is called the relation. Means the set of ordered pairs are called binary relations. Let us take the technical definition, which is consist in this point. Let A and B be sets, a binary relation from A to B, a subset R of A cross B. A cross B means is the Cartesian product. Cross is the indication of a Cartesian product. Means we analyze the variable of A and variable of B and just create some ordered pairs like A comma B, where A, the element A is belongs to the set A and the element B is belongs to the set B, is called the relation. So in a relation, in other words, we can say the relation for a binary relation R, we have R is a subset. So this is the sign of subset. So R is a subset of A cross B. A cross B is called as Cartesian products. We use the notation ARB to denote that A comma B belongs to the R, and ARB to denote that A comma B does not belongs to the R. Means the elements A, B is not belonging or not present in a relation R. So when A comma B is just an element of any set belongs to R. So A is said to be related to B by R. Let us take an example. Let A be the set of student and B be the set of courses. So student is a set 1 and B is an element of set 2. So courses is set 2. So let R be the relation that consists of those pairs A comma B, where A belongs to set A. Means A, the element A belongs to the student set and B belongs to the courses set. So if I'm taking another example, if Jason is enrolled only in CSE 20. So CSE 20 is a set 1 and Jason is an element and John is enrolled in CSE 20 also. So Jason and John is a part of set 1, which is called CSE 20. But John is an element which is also the part of second set CSE 21. So it is all about the relation. The pairs, the pair means the ordered pair which consists in set of elements. Jason is belongs to CSE 20 and John is also belongs to CSE 20, same as John is also belong to CSE 21. Means John is an element which belongs to two set which is called CSE 20 and CSE 21. That is belongs to R. But Jason, CSE 21 does not belongs to R. Means Jason is only belongs to the set 1. Here we have taken another example, example 2. I am explaining the through example 2. Let A be the student in a set CS. CS is a set 1 major. So set A, there are so many elements in set A like Alice, Bob, Claire and Dan. There are 4 elements which is present in set A. Let B be a second set which have courses the department offers. So B is another set which have the courses like CS 101, 201 and 202. So we specify the relation. So we conduct the relation between A cross B, means that is A cross B, which is called the Cartesian product. So we have taken in relation R all the elements of A is related to the all the elements of V. Like Alice is related to this, Alice is always related to second element of set B and first element of always related to the third element, means each and every element is related to the other set of elements every time, is called the relation. Like you have seen in this relation, Alice is related to all the points like CS1, Alice is related to so many parts. So here is representing the relations. We have representing the relations graphically also, and we can represent relation in table also. So we represent the relation in graphic, like Alice is making a ordered pair with element set of B and element of set A is ordered pair with CS201, and these are both is relatable with the same means Dan is relatable with CS21 also and Dan is relatable with CS2 also. So it is not a valid function somehow. Only one element is related to the one time. Here we have taken an example 3. So there are so many examples for representing a relation that you may understand properly. Okay, let us take an example 3. Let A equal to A have a set which is the value 0, 1, 2 and B is a set which have the elements A, B. Then 0, A and 0B, 1A and 2B is a relation. So this is a given relation on R. This is not we are forming, this is already a given relation of R from A to B. So this means, for instance, 0 is relatable to the element A, but that 1 is relatable to the element B. If we have conclude the R is a subset of A cross B, so we conclude the Cartesian product. Cartesian product means each and every element of set A is making the ordered pair of every element of set B, means 0 is pair with A, 0 is pair with B and 1 is pair with A, 1 is pair with B. Same as 2 is pair with A and 2 is pair with B. So here if we have given a relation R, so we have given so many elements which is belongs to the Cartesian product of this element, means R should be present the Cartesian product of A cross B. So this is a valid relation. Now the next topic is function as a relation. We have concluded a function in a relation. So we might remember that function f, we assume the function f from a set A to set B, assign a unique element of B to each element of A. So we have considered the graph of function f is a set of ordered pairs AB such that B equal to function of FA, since the graph of f is a subset of A cross B. So here is the definition, only the definition of function as a relation. We will conclude the function is relatively defined in a relation or not. Moreover, for each element A of A, there is exactly one ordered pair in a graph that has as a first element. So here is the another example. If I am taking a function as a relation, if R is a relation from A to B such that every element in A, means if R is conducted a relation in a function, so every element in set A is the first element of exactly one ordered pair of R, means it should be that every element of set A is making a pair ordered pair of R, then a function can be defined as R in its graph. So here is the another definition where we define a relation on a set. So earlier in previous video, I had discussed about a set. What do you mean by set? Basically, set is a collection of unordered pairs. But in relation, we are going to discuss about the ordered pair. Means the relation in a set, any relation can be exist, but in a ordered pair like A, B, A, C, B, D, or etc. So the definition of relation on a set is a relation on a set A is a relation from A to A. Means we have talking about a single set A. There is no second set we are including. We are only talking about a set A only. So the operation is conducting in a single set only. We are not including more than one set. So this is all about the relation on a set. We are talking about a single set which is making the ordered pair of itself. So this is called relation on a set. Let us take an example. I am taking a set A only. So it make the ordered pair by itself, means we have take A, another A, which is conduct the same value 1, 2, 3, 4. So 1 is ordered pair with 1, that is 1, 1. 1 is ordered pair with 2, 1 is ordered pair with 3, then 4. Then same as 2 is repeated with 1, 2, 3 and 4. Same as 3 is repeated with 1, 2, 3 and 4. So it is making the ordered pair. How do we analyze how many ordered pair can be accessed in a single set? So it is all about A cross A, means the Cartesian product of A cross A is relatively with the relation R. Now I am taking another example where you can understand properly. Here is the solution of this problem. Let A is a 1, 2, 3. So this is all about a relation. This is a given relation. This is a given relation where 1 can exist 2, 1 can exist 3, 1 can exist 4. 1 can make a ordered pair with 4. 2 can make a ordered pair with 3 and 4. 3 can make a ordered pair with 4. And 4 is not making the ordered pair because there is no any number which is greater than 4. So here is the relation is 1 can be paired with 2, 3, 4 and 2 can be paired with 3 and 4 also, and 3 can be paired with 4 and 4 is not pairing with anyone else because there is no number which is more than a 4. So here I am taking another example. There are so many examples behind the relations because you may understand properly what is the meaning of a relations and what are the operations is done behind during the relation concept. So this is the another example. Example 2. Let A be the set 1, 2, 3, 4. Here is the set A. Okay, which ordered pair are in the relation R? So it is this is asking how many orders pair or which ordered pair is consist in a relation R. The condition is given over here. Condition is all about A, B. So ordered pair must be only those elements where A divides only B. Means the elements which present in set A is divided by the elements presented in B set only. So we will consider only those ordered pair where they satisfy this conditions only. So let us check what kind of conditions it satisfy. Let set A and let we have consider set A and we may consider this is set B. So the elements A is making a pair with 1, 2, 3, 4 and 2 is making a 2, 4. Why? Because 2 can be divided by 2 only and 4 can be divided by 2 only. So 1, 2, 3, 4 can be divided by 1 only. So we have taken the ordered pair with 1. 1, 2, 1, 3, 1, 4 means 1 is divided by 1. 2 can be divided by 1. 3 can be divided by 1. So we can satisfy this property. Okay. Then second, 2 can be divided by 2 only. So we have taken a 2, 2. So 4 can be divided by 2. So we have taken a 2, 4. Now comes to the 3. 3 can be divided by 3 only. No other element can be divided by 3 only. Okay. So 4 can be divided by 4 only. That comes to 0. Otherwise, there are some rational numbers which is not possible in a relation. So this is the relation of order pair which satisfy the condition A divided by B. So this is all about the relation R. Now we have taken another example. You may calculate this example and we will go further check in next slides. Now here is the another concept in relation which is most important part of a relation, where in every exam there are so many questions may arise from these type of relations. So there are various type of relations can exist. First is reflexive, second one is irreflexive, symmetric, asymmetric, antisymmetric, and transitive. So we will discuss one by one for each and every properties of a relation. So first property of a relation is a reflexive. What do you mean by reflexive? If I am talking about in short, if there are any ordered pair consist in a relation R, and the ordered pair must be relatable to itself. Like if any element ordered pair is relatable with the same element of order pair, like this, A comma A means A comma A is called reflexive. A comma A means if any ordered pair comes 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. So any element which can make a ordered pair with itself, same element consists in a ordered pair, the property is called reflexivity. Okay, you can read the definition. Relations are elements is always related to itself. Like let R be the relation on a set of all people consist of pair XY, where X and Y have the same mother. Same mother means they are belonging with the same set, means no element is belonging to the other set. They have a same set and they have a same elements. Like X is always belongs to the X. For every person, X is called reflexive. Now here I am taking an example of reflexive relation. This is the sign of reflexive relation. Like this, I am taking an example. If one can make a ordered pair with one itself only is called reflexive. ठीक है. If I am taking an example, if a set 1 2 3 4, then 1 2 3 4 means 1 1 2 2 3 3 4 4 should be in a relation is called reflexive. Okay, so what do you mean by reflexivity? Okay, if there is no 2 2 in a relation R, so it is not a reflexive. Here you can check the R2. There is 1 1 2 2 3 3 and 4 4. It means it is a reflexive. It satisfies the property of reflexibility. Okay, now we are taking about 1 1 2 2 3 3, but 4 4 is not present over there, and there is a set 1 2 3 4. So 4 4 is also be present over there. It means it is a reflexive. Otherwise, it is not a reflexive. Now comes to the another example. You may check by considering the another example of reflexive, that this relation is a reflexive and not a reflexive. Okay, set 1 2 3 4 consists. It means in every relation there is a element should be present 1 1 2 2 3 3 and 4 4. The 1 1 2 2 there is no 3 3, this is not a reflexive. 1 1 there is no 2 2 3 3, so this is not a reflexive. You may calculate this relation 1 1 2 2 3 3 and 4 4, so this is a reflexive relation. Okay, there is no 1 1, this is not a reflexive relation. Okay, you may check 1 1 hai, 2 2 is also there, 3 3 is also there, but 4 4 is not present, so this is not a reflexive. Okay, 4 4 is also present in R5, sorry, so this is a reflexive. R6 is not a reflexive because there is no self-ordered pair. Its self-ordered pair is present 1 1 2 2. There is no 1 1 2 2 3 3 and 4 4 is present. Now consider the another types of relation, which is called irreflexive relation. A relation is irreflexive relation if every element is not related to itself, means it is totally opposite of a reflexive relation. If in reflexive 1 1 is present over there, but in reflexive whenever there is a 1 1 is present relation, so it is not reflexive. By default is a reflexive. Okay, you may check the condition. If making the ordered pair A comma A is not belongs to R is called irreflexive property. Irreflexivity is totally opposite of reflexivity. Here I am taking an example of reflexivity. You can check, like if reflexive, this is not all about the irreflexive relation. Now the third part of relation is symmetric relation. Here is the definition of property. What it called? It is called if if A belongs to B, then B belongs, sorry, if we may consider, if I am taking an example in symmetric, a relation R on a set A is called symmetric if BA belongs to R whenever AB belongs to R for all values of A. Means if AB in a relation, then BA should be present in a relation. It is called symmetric. If AB is present in a relation and BA is not present, then it is not symmetric. So for making the symmetric property satisfy, we need to check AB is present, then BA should also be present over there. Otherwise, it is not a symmetric property. We can check a relation R on a set is called, now here is the another example which is called antisymmetric. Antisymmetric means AB can be belongs to R, BA can be belongs to R, but only if when A equal to B, means when they satisfy the reflexive property, then they are antisymmetric, otherwise they are not. Means AB belongs to R and BA only belongs to R when A equal to B, otherwise not. Okay, so here is a example of symmetric relation. A relation is symmetric for every AB belongs to R and BA belongs to R. Antisymmetric, the definition is AB belongs to R, BA belongs to R. That is true, but only that is true only if A equal to B, otherwise not. Okay, so here is the other part of relation is asymmetric, which is totally opposite to the antisymmetric. Here AB belongs to R, but BA should not belongs to R. Means if I am taking an example, 1, 2 is in a relation, then 2, 1 should not be in a relation is called, then 2, 1 should not be in a relation is called and asymmetric. Means if we are taking an ordered pair in a relation, 1, 2 is present and 2, 1 is not present, then it is called asymmetric. If 2, 1 is present, then it is called symmetric. Okay. Okay class, so this is all about the types of relations. So this is all about for today, the types of relation, and we will discuss in next presentation. Here are some examples of the relation we will discuss further. Thank you so much.